Hello friends, today we are going to deal with the solar system. Actually, whenever we talk about the solar system, we know that solar system consists of the sun and its family members. Okay, but what are all the things which are present in the solar system we will be discussing today. Okay, yeah. So the solar system, right, is consisting of the sun, right, and 8 planets. Okay, asteroids, meteors, right, dwarf planets, satellites, and several of the dust particles. Okay, so first we will be going on with the sun. Okay, so when we talk about the sun, right, in our younger days when we were studying about the solar system, we might have studied that the sun is the father-like figure in the solar system. Why we have equated sun with the father, guys? Right, nowadays it may be gender biased, but why? Because the energy, whatever the energy which we are getting from the, it is only from the sun. That is the reason because of which we have equated the sun with the father of the solar system, guys. Okay, so where does the sun present? Okay, so we are talking about the galaxy, right, and we have said that the galaxy is a part of a supercluster called Laniakea. Okay, galaxy is the part of a supercluster called Laniakea. Okay, Laniakea is an Hawaiian word which means immeasurable heaven. Okay, so Laniakea is an immeasurable heaven and the galaxy is the part of that supercluster, and like that there are several superclusters present in the universe, guys, right. So within the galaxy where the sun is present, the sun is present at a distance of 30,000 light years from the center of the galaxy, and we have seen the other day that the galaxy is egg-like, and if this is the center, right, sun is present at a distance of 30,000 light years, because the total diameter of our galaxy is 1 lakh light years. Okay, the center will be having 50, right. So that is at the distance of 30,000 light years. So sun is present at a distance of 30,000 light years away from the center of the galaxy, right, and the sun, though it seems as if it is stationary, right, but the sun revolves around the galaxy, center of the galaxy, in an elliptical orbit, okay, with the speeds of 241 kilometers per second. Okay, with 241.4 kilometers per second, the sun is moving, guys, because of that high speeds. And when the sun is moving, right, the entire solar system is moving. There is a reason because of which we will not feel that movement, guys. Okay, as when you are seeing the earth, rotation of the earth, right, in the rotation of the earth, the gases are also rotating, but because they are in tune with the gases, we are unable to see their rotation. In the same manner, the entire solar system is in tune with the sun. That is the reason because of which we are unable to see the exact movement of the sun, guys. Otherwise, it is moving with the speeds of 241.4 kilometers per second, right. And the age of our solar system is 4.6 billion years, guys. Okay, the age of our solar system is 4.6 billion years, right, and the sun takes 250 million years, 250 million years to complete one revolution. So to complete one circle, the sun is taking 250 million years, and the sun's or the solar system's age is 4.6 billion years. So how many revolutions till now the sun has completed, guys? Okay, 1 billion is equal to how many millions? 1000, guys. Okay, 1000 millions equal to 1 billion. Okay, so already 19 because it is 4.6. Okay, 4, right, this is 4600 million years now, 4.6 means, right, and divided by 250, right guys. So it will be coming to, yeah, 18 point something guys. So we are in the 19th revolution of the sun surrounding the center of the galaxy guys. Okay, one circle 250, right, 4 circles 1 billion, right, 4 billion 16 circles, right, half billion 2 circles, 18 circles are completed and we are in the 19th circle or the 19th revolution guys. Okay, this is our solar system guys, right, the sun, okay, then the first 4 planets, right, then the asteroid belt and the next 4 planets like that. Okay, so like other than the sun, we have identified several of the stars in our solar systems which are several times bigger than our other stars in our galaxy guys. Other than the sun, we have identified several of the stars in our galaxy which are several times bigger than the sun. Okay, Trumpler is the star which is equal to 100 suns put together. Okay, yesterday we are talking about the neutron stars, right, just 10 to 25 solar masses, and this is 100 guys, 100 solar masses. Trumpler, right. Betelgeuse is the other star which was discovered which is equivalent to 1400 times that of the sun. Okay, and the largest known, okay, the largest known star in the universe is YV Scuti. YV Scuti is the largest star discovered so far guys, and that is 1700 times larger than the sun. Okay, that is 1700 times larger than the sun. Okay, and we have discovered one of the star which is closer to the sun guys. So the closest star to our sun is, generally in our textbooks or all the materials it is said that it is the Proxima Centauri guys. Okay, so they say it is the Proxima Centauri, but recently we have found out that it is the Alpha Centauri which is closest to the sun, not the Proxima Centauri guys. Because if you look at the you can have the small example guys, right. Suppose there is a sun in front of you, and if you are looking at the sun, you cannot see what is beyond the sun because of the glare what we are getting from the sun. So previously we were not having the optical instruments which can see beyond the sun. Even though sun is present, we were not able to see, right. So now we are having the optical instruments, right. Here is the sun, but we can see what is beyond the sun also. So previously what we are doing, we were not looking at the glare of the sun, we were looking in all the other directions, and we said that it is the Proxima Centauri which was close. But because of the new optical instruments, right, we have seen a star which is very much back to the sun guys, and that is the Alpha Centauri. Okay, so the solar system, what we said, it consists of the planets, asteroids, comets, meteors, etc. So we will be talking first about the asteroids guys. Sorry, first we will be talking about the sun. Okay guys, we will be first talking about the sun guys. So when we talk about the sun is accounting for 99.86% of the total mass of the solar system guys. 99.86% of the total mass of the solar system is concentrated in the sun alone. Okay, and the sun is made up of the plasma interwoven by the cosmic gravities guys. Okay, so the magnetic field is also present in the sun, which is making all the materials to be interwoven within it, and the matter which is present in the sun is in the form of magma, and it contains 74% of the hydrogen. The sun is made up of 74% of the hydrogen and 24% of the helium. Okay, sun is made up of sun is made up of 74% of hydrogen, 24% of helium, right, and the rest includes oxygen plus iron, guys. Okay, so these are the constituents of the sun, and all of these are present in the form of plasma interwoven with the magnetic field, guys. Okay, yeah. And when we talk about the sun is made up of 5 different spheres, guys. Okay, the central sphere is called as the nucleus. Okay, so the core of the sun is called as the nucleus, where the temperatures are ranging between 10 to 20 million degrees centigrade, guys. Okay, so the core of the sun is called as the nucleus, where the temperatures are around 10 to 20 million degrees centigrade. Okay, then comes the crown. Okay, so the nucleus or core is surrounded by the crown, guys, right, and here the temperatures are around 2 lakh degrees centigrade, because here we are telling that the circles are very near, guys, but they are very far, they are extending to the maximum extent, guys, right. Then comes the transition zone. Okay, the transition zone is having the temperatures of 1 lakh degrees centigrade. This is subject to correction, guys, crown's temperatures, right, but the transition zone's temperature is 1 lakh degree centigrade. Okay, then the fourth sphere is called as the chromosphere, right, and its temperature is 32,472 degrees centigrade. Okay, guys, 32,470 or 72 degrees centigrade is the temperatures of the chromosphere, guys. And the fifth sphere is the photosphere, right, and the photosphere is having 6,000 degrees centigrade of temperature. Okay, 6,000 degrees centigrade of temperature, right, and the glare what we see, guys, is called as the corona. Okay, the glare is called as the corona. Okay, yeah. So within the sun, guys, right, 40 lakh tons within the nucleus of the sun, 40 lakh tons of hydrogen is getting burned for every second. Every second, 40 lakh tons of hydrogen gets burned in the nucleus, right, and the energy which is emitted out from the nucleus, guys, it takes 1,70,000 years to reach from nuclear to the photosphere. Okay, from the center to the photosphere, the energy takes 1,70,000 years to reach, guys. See, these are with this all the things which we have got from the simulation experiments which are being conducted by several of the astrophysicists and the scientists, guys. Okay, so imagine what is the distance from the core to the photosphere, because the energy is taking 1,70,000 years, guys. Okay, and from the photosphere of the sun, we have said that our sun is a variable star yesterday, remember, twinkling star, right. Why it is called twinkling star? Because several of the energy particles are being released from the sun, they are thrown from the photosphere of the sun, guys. Okay, sometimes they will be coming away from the gravity of the sun and they come towards the earth, and then at that time we will be calling them to be the solar storms. Or several times these glares or the photon molecules, photon particles, they will be falling back into the sun itself, and they are called as the prominences. Okay, so the photon particles which are ejected from the sun, when they fall back, right, they are called as the prominences. So, when the prominences are more, the light energy given is excess, more. Okay, and on the sun, okay, on the surface of the sun, they have identified some sunspots, the dark parts on the surface, guys, sunspots, right? And we are able to see the sunspot cycle from our earth within an interval of 7 to 11 years. Okay, every 7 to 11 years of interval, right, the earth is rotating and the sun is rotating, right? So, what happened? The sunspots, wherever the sunspots are maximum, that will be facing the earth, and that is coming with a period precision of 7 to 11 years, guys. So, previously people thought that whenever the dark spots are facing the sun, was facing our earth, whenever the dark spots are facing our earth, previously scientists thought that the energy emitted is less, but now it is seen that during the dark spots or the sunspot cycle, the energy emitted is more, guys, right? For this, our best of the understanding where we can give an example is related to the boiling of the molten material or the heating of the iron, guys, iron ore. If you look at the iron ore getting heated, first it will turn orange color, right? But when it is heated to the maximum extent, it will be turning the black, guys. So, the dark spots are the black spots, right? During that, it is giving more of the energy, not less of the energy, right? And to study the sun and its surface, guys, lots of solar missions are active in the world at present, right? The NASA has given out the solar missions to study the chromosphere, to study the corona, right? And the upper outer temperatures and the atmospheres, right? Like that, Japan has sent, France has sent, okay, China has sent, even India has sent the solar mission, guys. Okay, India is about to send, guys. Last year it was to send, but because of this all corona and all, it got stuck, guys. Aditya 1. Okay, and that Aditya 1 will be stationed very far from the sun, like we are not going nearer to the sun, guys, because the temperatures there are very huge, and all the materials and the metals which are found on the surface of the earth, they will be getting vaporized at 4 to 5,000 degrees centigrade, guys. Okay, and here for several kilometers from the sun, the temperatures will be around 5 to 6,000 degrees. So, we are placing the Aditya solar mission at Lagrange position 1, guys. So, that is the point where the exact axis from the earth is being met, guys. So, here somewhere we are placing the solar mission Aditya, and from there we are trying to study the corona, guys. Okay, so there are several of the solar missions because we want to know what exactly is present in the sun and what is the thing which is happening in the sun. That is the reason because of which we have come to know that there are several of the spheres present, right? And the temperatures are varying from 10 to 20 million degrees centigrade to just 6,000 degrees centigrade, guys. Okay, yeah, this is related to the sun, guys. Okay, yeah, and you know, like 60 million photon particles are ejected from the sun per second, guys. Every second 60 millions of photon particles are ejected from the sun's surface. So, in whichever the direction they are going, in that direction, so you will be feeling much more hotness, guys. This is related to the sun. Okay. The number 1 or the father figure of our solar system, guys. Okay, then we will be talking about the asteroids. What are these asteroids? Right, asteroids are the rocky or metallic objects, guys, having varying shapes and sizes. Okay, asteroids are the rocky or metallic objects with varying shapes and sizes, and they are present in billions of numbers. They are present in billions of numbers rotating, right, in between the Mars and the Jupiter, guys. Okay. So, in between the Mars and the Jupiters, billions of rocky and metallic objects are revolving around the Sun in the form of a belt, and that is called as the asteroidal belt, and the asteroids are the metallic and rocky objects, guys. The asteroids are also called as the pioneer planets, guys. Asteroids are also called as the pioneer planets because, as we said, right, between the Mars and the Jupiter, billions of these are moving, guys. Billions of them are moving with certain speeds. Okay. So, there is a possibility of the changing in the shape because each and every object which is trying to move, guys, it will be trying to lessen its surface tension. Okay. So, there is a possibility of one asteroid getting circular. Okay. So, when one becomes circular, its velocities will be differing from that of the others. Okay. When the velocities differ, automatically what happened? When everyone is going with the same speed and suddenly one person or one object increases its speeds, it will be leading to collisions. And one collision may lead to several cascading collisions because billions of them are moving in the belt, guys. Right. So, when all of them struck together, right, automatically the bombardments will be increasing the temperatures. When the temperatures are increased, automatically they are made up of metallic. Rocky means all the minerals. So, they all will get melt, guys, because of the increased temperatures. They melt, and in due course of the time, there is a possibility of them getting coagulated to form a new planet. That is the reason because of which the asteroids are called to be the pioneer planets, guys. Okay. So, when we talk about the distances in the universe, guys, astronomical units we say. Okay. So, whenever the distances are being measured in our solar system, guys, only in our solar system we are calling them to the astronomical units. Away from the solar system we are calling them the light years. Okay. So, when we are trying to measure the distance away from the solar system, we are calling them as the light years. Within the solar system, astronomical units, guys, right. One astronomical unit is equivalent to the distance between the earth and the sun, and that is nearly 150 million kilometers, guys. So, one astronomical unit is nothing but 150 million kilometers. Okay. Yeah. So, the asteroidal belt is present at a distance of 2.6 AUs, astronomical units, from our earth, guys. 2.6 astronomical units from our earth. This is related to the asteroids. Okay. Next comes the comets. Okay. The comets are also called as the tail stars, guys, or icy bodies or dirty snowballs. Comets are also called as the tail stars, icy bodies or dirty snowballs. Okay. So, these comets are made up of the ammonium and methane gases and ices, guys. Okay. So, these comets are made up of the methane and ammonium ices and gases, and they are present in a place called as the Oort cloud. Okay, at a place within our solar system called as the Oort cloud, right, which is at a distance of 50,000 AUs. 50,000 AUs from our sun, guys. So, what is happening? These dirty snowballs or the comets are moving, guys. within the solar system, they are moving haphazardly. Okay, so when they are nearing the sun, so they are coming from here, so they are at a distance of 50,000 AUs, guys, right? So they are moving haphazardly within the solar system. So when they are nearing to the sun, and when that nearness is being visible from the earth, clear, guys? So what happened when they are nearing the sun? Because of the increase of temperatures, the ices or the gases will be getting vaporized, right? So this dirty snowball is coming this way, let us suppose. Okay, so when the gases melt, automatically what happened? The gases will be trailed behind. Vaporized materials will be trailing behind. So it seems as if they are the comets, guys. Okay, so the tail stars, hence they are called as the tail stars, because the body is having a trail of a tail, hence they are called as the tail stars. And where they are present? They are present in the Oort cloud, which is present at a distance of 50,000 astronomical units from the earth, guys. Okay, next comes the meteors. Okay, the meteors, guys. So what are these meteors? Again, meteors are the metallic objects. They are having interplanetary orbits. So the comets were moving within the solar system, 50,000 astronomical units, guys, is very huge, right? Whereas the meteors are moving within the planets, guys, right? We have seen the sun, and the planets. Here you are having the asteroids. Okay, so what is happening? These meteors are metallic objects. They are moving interplanetarily, like this. Okay, so they are moving within the planets with different orbits, guys. So automatically what is happening, right? Whenever, suppose this is the earth and this is the atmosphere of the earth, right? Whenever the metallic objects or the meteors are entering into the earth's atmosphere, this is the earth, guys, this is the earth's atmosphere. So whenever they are entering, right, they are coming with lots of speeds. Okay, so what happened? The friction caused by the dust particles, right, will make them to get burned off, guys. Okay, so when the meteors get burned off within the atmosphere, then they will be called as the meteorites. Okay, when they get completely burnt off within the atmosphere, they are called as the meteorites, and they are coming in several hundreds of numbers, guys, and with the speeds of hundreds of kilometers per hour or second. So automatically when they are coming with maximum of the speeds, right, what happened? The friction will be causing them to get burned off, guys, right? And most of this meteoritic shower is seen in the upper atmospheric layers, guys. They are called as the mesospheres. Okay, so the meteoritic shower is seen first in the mesosphere and then they will be coming towards the earth, guys. Okay, if they are present above the mesosphere, we cannot visualize the meteoritic showers, guys. Why we are calling them as the showers? Because it is not one meteor which is coming. Hundreds of them will be coming and hundreds of them will be burning and falling towards the earth. When they get completely burned off, they will be called as the meteorites, right? Suppose by chance the bigger rock particle, bigger metallic particle, the meteor, right, after getting burned also it is still intact and it has struck the ground. If it strikes the ground, it will be called as meteoroid. Meteoroid. Okay, guys, meteoroids. And there are theories present which says that because of the striking of the meteoroid, right, the dinosaurs got perished, guys. Okay, there is a theory which says that a big meteorite has struck the earth, and because of that the earth got jolted, right, and the entire dust particle, the earth's atmosphere was filled with the dust particles, right, and that has killed the dinosaurs. Okay guys, yeah, so these are the meteors, right. If they are getting burned off, they are called as the meteorites, and if they are striking the earth, they will be called as the meteoroids, guys. Okay, yeah. Next we will be talking about the dwarf planets. Dwarf planets, guys. The dwarf planets are also called as the Plutoids, Pluto-like objects. Okay, dwarf planets are also called as the Plutoids or the Pluto-like objects, guys. Right. So what are these dwarf planets? Any of the object, if it gets rounded under its own gravity within the solar system, guys, other than the planets, any object, if it gets rounded under its own gravity, that will be called as a dwarf planet, guys, or Plutoid. Okay, dwarf planet or Plutoid. It can be anything, guys, other than the planet, because lots of metallic and rocky objects are present within the solar system. So if one gets circular, rounded, that will be called as the dwarf planet or the Plutoid. Okay. So in all our textbooks and the materials, they say that there are 5 Plutoids present in our solar system. Okay, there are 5 Plutoids present in our solar system. But recent discoveries are saying that there are 16 of the Plutoids are present in our solar system, guys. Okay, the materials and the books, they say that there are 5 Plutoids present, but the recent discoveries are telling that there are 16 of the Plutoids present in our solar system, guys. Right. So this has not come to the public yet. So we will be studying only the 5 of the Plutoids or the dwarf planets, right. So out of that 5, number 1 is Pluto. Okay, number 1 is Pluto, number 2 is Haumea, number 3 is Makemake, and number 4 is Ceres, and number 5 is Eris. Okay, so Pluto, Haumea and Makemake, these 3 are present in the Kuiper belt. These 3 are present in the Kuiper belt, guys, right, and Kuiper belt is the belt which is present beyond the Neptune. Okay, so when we are talking about our solar system, last one is the Neptune. Okay, anything which is present beyond the Neptune is called as the Kuiper belt, guys, and that is extending between 20 to 50 AUs. Okay, Kuiper belt is extending between 20 to 50 astronomical units, guys, right, and Pluto, Haumea and Makemake are present in that Kuiper belt, right. Yeah. Next is the Eris, 5th one. The Eris is present in the scattered disk. Scattered disk is present beyond 50 AUs. Okay, beyond 50 AUs or beyond the Kuiper belt is present the scattered disk, and there we have found out one of the dwarf planet called as the Eris. Okay, so the Pluto, Haumea, Makemake and Eris, they are all present beyond the orbit of the Neptune only. Okay, so any object which is present beyond the orbit of the Neptune is known as the trans-Neptune object. And this was our prelims question, guys. What are TNOs? Was our prelims question. TNOs are the trans-Neptune objects, right? The objects or the bodies which are present beyond the orbit of the Neptune. Okay, yeah. Then this one, the Ceres, is present in the asteroidal belt. Just now we are talking about the asteroidal belt, and we have said that there is a possibility of one of the asteroid getting rounded, Okay, so already one got rounded, and that is Ceres, guys. So in the near future, there is a possibility of new planet to come up in the asteroidal belt. Okay, so why this Pluto has been taken out from the ambit of the solar system? Because previously the Pluto was the part and parcel of the solar system. Okay, so any of the planet, any of the object should be called as a planet, guys, in the solar system. It should have its own orbit, right, revolving around the sun, and that orbit should not cut the orbit of the others. Okay, but Pluto's orbit was something much more elliptical, guys. Okay, if this is the last one, Neptune, last one, guys, Neptune's orbit, right? Pluto's orbit was elliptical and it was going like this. Okay, what was happening? Sometimes it was becoming second last and sometimes it was becoming last, because it was cutting the orbit of the Pluto. That is the reason because of which it has been taken aside, because the planet should be the objects which should have their own orbit and they should not interfere with the orbit of the other planet. But Pluto's orbit was interfering with the Neptune's orbit, guys. That is the reason because of it has been taken out and it has been kept aside and called as the dwarf planet, guys. So this is related to the dwarf planets of our solar system, guys. Yeah. Next we will be coming with our planets. Okay. So when we talk about the planets, right, the first four of them, guys, the Mercury, Venus, Earth and Mars, the first four of them are called as the inner planets or the terrestrial planets. Okay, why they are called as the terrestrial planets? Because their components are similar to that of the Earth, guys, rocky and metallic. Even the asteroids are rocky or metallic. Even the meteors are rocky and metallic. Okay, so because all of these four are made up of the components similar to that of the Earth, they are called as the terrestrial planets. And because they are inside of the asteroidal belt, okay, they are called as the inner planets, guys. This is the asteroidal belt present here. Then you will be having the Jupiter and the rest, guys. Okay, so because they are present towards the inside of the asteroidal belt, they are called as the inner planets. And they are all made up of rocks and metals, guys. Okay, they are made up of rocks and metals. And because they are made up of rocks and metals, right, their densities are very high and their sizes are very small, guys. Okay, so all these four are of smaller sizes only, but their densities are very high because they are made up of rocks and metals. Okay, yeah. So the Mercury is the smallest of all. Right, guys? Mercury is the smallest of all, and Venus is the brightest of all, guys. It is the brightest of all the four. There is a reason because of which Venus is called as the morning star or the evening star, because just in the twilight periods, guys. What is the twilight? The light which is seen after the sunset or before the sunrise. That is called as a twilight period, guys. So before the sun is coming above the origin, when the sky is clean, guys, the one and only bright star which is shining like, that is the Venus, guys. That is the reason because of it is called as the morning star. And once the sun set also, before the other stars come, the bright star-like structure which is seen in the skies is nothing but the Venus. Hence it is called as the evening star. It is called as the morning or the evening star, guys. Right? Then the Earth. We know that it is a fertile planet. Right? So previously the Earth was called as the blue planet, guys. But now it is called as a green planet, because there are two more blue planets which have been discovered so far or identified so far. Uranus and Neptune are also the blue planets, guys, blue and green planets. So this is the green planet with life, guys. Okay. Next comes the Mars, right? We are now having several of the missions, right, towards the Mars to identify the atmosphere of the Mars, okay, or its feasibility for the survival of the life, guys. So this is related to the inner or the terrestrial planets. Okay. Next comes the outer planets, or they are also called as the Jovian planets, guys. Okay. So the outer planets are also called as the Jovian planets, right. Previously all the four were called as the gas giants, guys. Previously all of them were called as the gas giants, and they thought that all the four are made up of the hydrogen and helium gases. Okay, but recent discoveries are telling that only the Jupiter and Saturn should be called as the gas giants, right, and the Uranus and Neptune should be called as the ice giants, guys. Okay, and these are the green and the blue planets. Jupiter is the biggest of all, right, guys? Yeah, and you know the Saturn has been witnessed with several rings, and all these rings are having several of the satellites rotating around them, guys. Okay, and recent discoveries are also telling that the Jupiter is full of gases. And one more theory has come down, guys, which is telling that because of the presence of Jupiter, right, the emissions which are coming from the galaxies are being stopped and the life on the earth is getting survived. Okay, so more the more scientificalities, more the more we will be having the discoveries, guys. So we will be knowing more of the information. Okay, so at present for us this is more than enough, guys. Okay, so in between the Mars and the Jupiter, yeah, so because they are made up of the gases, right? So what happens when they are made up of the gases? Their densities will be low, right? Their densities will be less or low, and their sizes will be very big. That is the reason because of which they are called as the gas giants, guys. Okay, yeah. Next, in between the Mars and the Jupiter, we have already seen that there is an asteroidal belt. Okay, in the same manner, in between the Mars and the Earth, they have identified some unstable minor planets, guys, which are called as the centaurs. Okay, so in between the Mars and the Earth also, right, lots of planets, small minor planets are moving, and they are called as the centaurs, right. And it has also been identified that within the Earth's orbit, if this is the Earth's orbit and Earth is going, guys, right, within the Earth's orbit there are several of the metallic or rocky objects which are moving with the same speeds that of the Earth, and they are called as the Trojans, guys. Okay, so any of the object which is rotating within the orbit of the Earth is called as the Trojan, right. In 2000, from 2010 they are discovering several of the Trojans, guys. So the first discovered one was 2010 TK7, and thereafter several of the Trojans have been discovered so far. Okay, guys, right? Yeah. So we will be talking about the Greco-Roman names of our planets. The Greco-Roman names of our planets, guys. Okay. Mercury is the Roman god's name, guys, and it is the god of commerce. Okay, so the Roman god of commerce is Mercury. There is a reason because of which it has been named, guys, right. So why it has been named Mercury? Because of its speeds. Because god of commerce, commerce is nothing but the business, guys. So the people who are into the business, they will not be keeping quiet. They will be moving from one place to another place for their survival or to do the business, commerce, right. So this is moving with maximum of the velocities, right, and its orbital speed is very, very high, guys. That is the reason because of which it has been named as the god of commerce, right? And the Greeks call it Hermes. Hermes is nothing but the messenger of the god, guys. Greeks call it Hermes, the messenger of God. So what the Greek people say? When he is the god, what is necessary for the god to move, guys? They will be having lots of messengers who can do the work for the god. That is the reason because of which Greeks are calling it as the Hermes, right? Next, Venus is the goddess of love and beauty, guys. Goddess of love and beauty. Okay, and Greeks call it Cupid. Cupid, right? The guy with the arrow, guys. That is the god of romance. Right? Yeah. Next, the Roman name and the Greek name of our earth is Gaia, guys. Gaia is the both Roman and the Greek name of our the earth. Gaia means a fertile planet, the planet with the life. Okay, because out of all the planets, only one planet is fertile, right? And the Gaia is said to be taken from the Sanskrit word gau. Cow. Okay, guys. So the cow is associated with the fertility. That is the reason because of which the earth planet is also associated with the same word Gaia, guys, fertility. Okay. Next comes the Mars. Okay, it's the Roman god of war, guys. Mars is the Roman god of war, right? Greeks also called it as the god of war, but their god of war is Ares. Right? We have seen Eris, that is one of the dwarf planets, that is Eris, and this is Ares, guys, Aris, Ares, god of war, Greek war of god. Then comes the Jupiter. Romans call it as the godfather, right? Whereas Greeks call it as the king of the gods, guys. And the king of the gods according to the Greek mythology is nothing but the Zeus. Okay. Yeah. Next comes the Saturn, Romans god of agriculture. Okay, Saturn is the Roman god of agriculture and Greeks call it as Cronus, Cronus, again the god of agriculture. Okay. Then the Uranus, guys. So this is the only planet which has been named after the Greek god. Uranus, the god of heaven or sky. Okay, and that Uranus is called as Caelus by the Romans. Romans called Uranus as the Caelus. Caelus also means the god of the heaven or the sky, guys. Okay, and the last one, the Neptune, the goddess of the oceans or the seas. Right? Neptune is the goddess of the oceans of the seas of the Romans, and Greeks call it Poseidon, again the goddess of the seas or the oceans, guys. So these are the Greco-Roman names of our planets. And we have already seen that the Pluto is considered as a dwarf planet, not as a planet because it is sometimes the ultimate and sometimes the penultimate orbit. Okay. So sometimes it is the last planet, sometimes it is the second last planet, guys. And all the planets which are present in our solar system, guys, they are present according to the Titus-Bode's law. This was our prelims question, guys. The arrangement of the planets in our solar system is according to the Titus-Bode's law. This was our prelims question, guys. What does the Titus-Bode's law says? The Titus-Bode's law says that all the planets which are present in our solar system, guys, okay, all the planets which are present in the solar system, they have got some special type of arrangement. So the planet which is present, let us suppose this is the sun and these are all the planets, guys. Okay, so let us talk about our earth. Okay, so what it says, the distance between the earth and its previous, the Venus, right? So distance between the earth and the Venus is twice the distance between the Venus and the sun. So each and every planet tends to be roughly twice as far from the sun as its sunward neighbor. Okay, so this is x, this is 2x. This distance is doubled here. So sunward neighbor, the distance between the sunward neighbor is double than its distance, guys. So each planet tends to be roughly twice as far from the sun as its sunward neighbor. So this is the sunward neighbor. For Venus, the Mercury is the sunward neighbor. So this is the Titus-Bode's law, guys. Okay, this was our prelims question. Okay, guys. Yeah. So we'll be stopping here. Okay.